Hi, I'm an old guy and I do maths, and today I thought we'd look at the inverse of y equals root x. A student of mine raised this with me. She was curious about what might happen when we found the inverse. Finding the inverse is not hard to find. She had no problem with that. She was just curious about what the outcome might be, and I'll get into why she had good reason to be curious. So let's just find the inverse of this. So if y is equal to root x, then we simply swap x for y as is normal, and as we need to get y without the square root sign, we square both sides, so we wind up with y equals x squared. Now, her question revolved around this. So this is what the graph of x squared looks like. Y equals x squared. Its domain is all positive. Its domain is all positive and negative real numbers, and its range is all positive real numbers. Now, if we take a look at the graph of y equals the square root of x, so y equals the square root of x, and it's implied that this is the positive square root of x. Unless we see a negative in there, we're not going to be drawing anything down here. Now, when we invert this, what we do is we effectively reflect this graph in this line. Okay. So, what really does that mean for the outcome? Well, the first thing to note here is that the domain of this function is equal to positive real numbers. And when we swap domain and range, when we invert this, because if x becomes y, then domain becomes range and range becomes domain, we get an interesting, well, what I think is an interesting result. So we're going to have y equals x for our inverted function. The range is going to be what the domain was here, which is positive real numbers. And that's going to mean that the inverse of y equals root x is going to look like this. Now, that makes perfect sense when you see it as a reflection here, but it takes a little bit to get your head around, because I think that people who have asked me about this have thought, well, the inverse of y equals root x is y equals x squared. Well, yes, that's true. But when we invert a function, we have to have regard to what the domain of that original function was, and obviously then what the range of that original function was. Now, the range of this function, as you can see from this, was also positive real numbers. So the domain of this function is going to be positive real numbers as well. So this is what the graph of the inverse of y equals root x looks like because there is, unless we're told that this includes the negative roots of x, unless we're told that, the implication is that it's confined to this, and we have this domain and range, and so we wind up with this domain and range when it comes to graphing the inverse of y equals root x. Thanks for watching. See you next time.